Hello everyone, welcome to this session. On data serialization in C of PIC microcontroller. I'm a host, Dr. Husna, and today we'll explore how to efficiently transmit and receive the data in the microcontroller based system. So here we can see this before going to this serialization, we'll see what is serializing the data. Serialization is the process of converting the data into the formats that is suitable for the transmission. So here we can send the data in the form of bit by bit. So we have the two primary methods of sending the data transfer in serially. So first is we can by using the serial port, we can able to transfer the data, but we have only the limited control over the sequences. Whereas there is one more method that is like bit by bit transferring. That is, we have the full control. For commonly we use the LCD or less ADC or an EPRO. So to we'll see this understanding this data serialization is something very crucial. So in C, for effective communication system, data serialization is very important for efficient communication between the microcontroller and peripherals. So next we'll see the serializing the data, and here you can see the program. So I have written the program for the LSB of first shifting right. So let me examine. We can serialize the data by shifting the bits to the right and sending the LSB bit first. So here you can see this code where here we have mentioned we are going to send the data of bit by bit, and here I have written the sending the data of 44 via the port C. So each bit I'm going to send by using the port. Each bit I'm sending via the ports. So here first thing is we have to initialize the data. So I have used the con byte to initializing the data, and we use the tris register, or as we can say that I have registered of tris bit of tris C0. So that is I'm going to configure the RC0 as an output bit, and so I have kept as a loop. The loop iterates for the 8 times, that is of LSB, by shifting the bit to the right. So, and this method is very useful for interfacing the data formats. So next, in some devices we can see this data can be sent to the most MSB bits. So in such cases we can able to modify the data by shifting the bits to the right. So here you can see this program where the program is initialized with the con bits of here I'm going to send the data of 88. So I'll iterate this loop, and now I'm going to shift the bit to the left side, and we are going to excite to the sending via the port C. So this technique is often used in the serial port communication interfacing, and as well as certainly we can say we can use this logic in the LCD interfaces. So next is the we have seen how to transmit the data, and now let's see how the serial port will receive the data. So this program, you can see this here we are using this RB0, that is I have used a reg A. Reg A is initialized to store the receiving data. This loop will be shifting the registers right, and we are going to insert the new bit of the MSB. So finally we are receiving the data of the port D. So this method is used to initialize the receiving the data of LSB first with the serial transmission. Next, we can conclude the serial transmission, data transfer is essential in microcontroller application. So there we are using the two methods, that is of shifting right and shifting left. Shifting right is LSB first, and in shifting left is MSB first. So we have understood what is the bitwise operation in C is used for enhancing the efficiency. So by mastering the data serialization, you can efficiently interface PIC microcontroller with the various peripherals and external devices. So example is LCD interfacing. The LCD interfacing serial communication enables display updates without using the multiple pins. So we are updating only with a single pin with the multiple data. And the sensor communication, we use the data in the form of ADC and other sensors, which is transmitted serially. And EEPROM interfacing is many memory modules which uses a serial data transfer for reading and writing the data. So what are the challenges and solution we can get is like there will be a solution of synchronization issues. So we will use the clock signals as an in SPI or I2C, and sometimes we get the challenges like noise in transmission. So we implement the error detection techniques and speed consideration. So we have to see the choose the proper baud rate. So thanks for watching.